Okay, let's start with Zendoo and in particular with the mentioned backward transfer requests. Okay, today we started the final code review because the implementation was finished and the first level of code review was already performed. So currently is ongoing and we will continue during this week. A couple of changes, change requests were already requested and have been identified, and they are proceeding with these changes right now. Okay, always related to Zendoo, in particular seized sidechain withdrawals. Okay, for what regard the seized sidechain withdrawals, even here, also here, change requests after first code review are currently in progress, and then we will proceed with the final code review. The other topic related to Zendoo are the customizable certificate fields. And you remember, these fields are useful for the seized sidechain withdrawal mechanism. So if for any reason a sidechain got seized for any reason, we want to provide a way for users to withdraw the funds from that sidechain. And so even if the sidechain isn't working anymore, how the user will be able to prove that they have still some coins in the sidechain. And for sure, we don't want the main chain knows the logic of the sidechain and the structure of the sidechain. So this is mandatory for us because we want to have any kind of sidechain out there, and we don't want the main chain knows the logic and the structure of the data behind it. So how to do it? With each certificate, the sidechain has the possibility to publish some custom fields. And these custom fields are validated by the snark proof of the certificate. And within these custom fields, there could be, a sidechain developer can structure these custom fields to contain data that can be used for providing proof of having still some coins in the sidechain. So let's say we had some coins at a specific epoch on the sidechain side, and we publish a state in the main chain that, let me say, give evidence of that, let's say, in a succinct way. And also in the subsequent certificate, there are some information that shows that, or give the possibility to the user to prove that he still have the coins there. And these are custom fields. You can see them as custom fields. And then the seized sidechain withdrawal mechanism, when the sidechain is not publishing any more certificate because it's seized, the seized sidechain withdrawal mechanism, by using this data, will be able to provide proof that a user still has the coin there in the seized sidechain. In this way, we will be able to provide the possibility to the user to withdraw even from a seized sidechain. And this is a quite key component of our model because provide much more security than many others out there. So specifically, coming back to the customizable certificate fields, the design activities were already done, and the development is also in progress. And in particular, currently we are adding the test, and so we are almost ready for the first level of code review. Okay, let's now switch to Zendoo, and in particular to the reindex improvements. Okay, in the last weekly update, we announced that we almost completed some improvements to the blockchain reindex process. And these happened after some members from the community highlighted, some degrading poor performances in the syncing and the reindex phase. So the first analysis showed, let me say, an issue that was preventing the reindex from using the checkpoints. So making it let me say, unable to use the faster checks they imply. So even if you had the checkpoints, the reindex phase were not taken in consideration then. So as expected, after having implemented the fix, the reindexing became faster. But then we did a new benchmarking analysis that clearly showed that shielded transactions were playing a role in these, let me say, worst performances, no? And so specifically, I mean, also in the reindex, after we introduced the graph 16 for the shielded transaction. So what we identified that the shielded transaction full verification for graph 16 was performed also when the checkpoints were active. And moreover, that some non-needed operation were executed even for all the PHGR shielded transaction. So these improvements, I mean, re-enabling checkpoints were, or better, disabling some checks when checkpoints were enabled for graph and also for PHGR. So these improvements made not only the reindex but also the sync from scratch much faster. And so after having tested the performance, we finally have some proven results. So running, for example, on a virtual machine with medium resources, we pass the reindexing process from 5.5 days to 11 hours and a half. And the syncing from around 3 days to 12 hours. So a huge performance improvement here. And we hope that users are going to be happy about that. Okay. Now let's switch topic and go on with the proving system. That is another key element, but on the sidechain side, but you also affect the main chain, and we will see later why. So we are working on a modified version of the Marlin proving system. So we are introducing a new proving system in reality. And one of the things that we have introduced is the co-boundary sum check that speeds up some part of the proving system, and in particular, the implementation of the co-boundary sum check is already done, and the first level of code review also performed, and now it's ready for the final code review. Always related to the proving system, as anticipated the previous week, on the sidechain side, for performance reason, we will use this new proving system for intermediate proofs. But for the final certificate, we want to end up with a different kind of proof that is going to be very similar to a regular Marlin proof. So in particular, for the intermediate proofs, and what I mean for intermediate proofs, let's say, on the sidechain side, do you remember, we want to prove the whole history to be able to provide a valid proof for the certificate. So we are doing recursive proof composition. Each transaction must be proven, and then we have to take these proofs, merge them together, and finally end up with a final proof that proven the history of this sidechain. So when I speak about intermediate proofs, I'm talking about the proofs that are generated for each, for example, transaction in the sidechain and also the merged one. But I'm not talking about the one that we will provide within the certificate to mention. So coming back to the intermediate proofs. For the intermediate proofs, as you can imagine, these intermediate proofs must be as fast as possible, because there are many, and so it's important that we can produce them with the lower resources as possible and merge them with lower resources as possible. So for these, we are also introducing, this proving system that is also based on Marlin, and that is avoiding some of the most expensive checks, and by using deferred arithmetics and amortization. I mean, it's something similar to what also Halo is doing, but we're doing that with Marlin. But as previously mentioned, for the certificate proof, we need to verify, we need to get rid of, of these amortized part and these deferred arithmetics. And I will not go too much in details about why, but we have to get rid of them. And for this reason, we need to have, a circuit, a gadget, so a way to generate a proof that get rid of them. And so for this reason, we are implementing a gadget that simulate the arithmetic of one field to another, and so to be able to provide this finalized Marlin proof. And this is something that we are currently, working on, because the design was already completed. Okay, and regarding always the proving system, we also started working on the batch verification of delogged hard parts. I mean, I will try to be short here. Let's say in a main chain block, we could have many side chains in parallel providing a certificate. This means that we have to verify multiple certificates in a block. But the certificate verifications means proof verification. And this means, verifying that, let's call them the delogged hard parts. So the biggest portion of the time needed to verify a proof is the MSM that can take several milliseconds to be performed. So if you multiply several certificates for a single block, you have to multiply the milliseconds used by each one of them. And so, so this will increase the delay of propagating the block, and this is unacceptable. So, but there is a solution for that. And so we can batch, the verification of them. And so to be able to, batch all the multiscalar multiplication of all the proofs in a single MSM. And so here the design, is still ongoing, but the implementation will follow soon. Okay, last part regarding the proving system is the multi-point, multi-poly batching. And our modifying Marlin protocol require for MSM to be verified, but also here we can use a similar concept as the one previously described to batch all of these MSM into just a single one. And so this is another thing that we're working on, and here the design is already completed, and the implementation tasks are currently in progress. Okay, for the proving system itself, let's go to the SDK, and in particular, our first version of the base fee scheme. Okay, and this is related to the SDK. We started working on the base fee scheme for the SDK, and this is currently, the implementation is currently in progress, and we are in the middle of development. And so we will keep you updated on this during the next week. Okay, I think that should be everything. Sorry if it was a little bit long, but that's it.
Thank you, Alberto. Sorry to intercept, Angie. We saw a comment on Discord. We'd like to clarify this.
Yeah, okay, maybe I was not fully clear about the intermediate proofs. Okay, the intermediate proofs live only on the sidechain side. So there are proofs that are generated. So let's say we have a forger on the sidechain side that want to include some transactions. This needs to be proven, and a final block proof should be provided. So in the final model, we have, let me say, a decentralized network of provers that compete and contribute to generate these proofs. But these proofs stay on the sidechain side, and even they are not even, let me say, stored individually in the block. But in the block, we are going to include just the final proof, the merged one of all the proofs that were related to the transaction that we included in the block. So the number of, let me say, intermediate proofs doesn't have any kind of impact on the mainchain side. Mainchain doesn't know them. Mainchain knows just the final certificate proof that is, let me say, created at the end of the epoch by the sidechain. So we can forget about all the intermediate proofs, even about the blocks proofs. So I mean, I hope that this clarified better what I was saying before.